Hello, everyone. We will start like in 3 minutes while waiting for the others to join. Yeah. Will you please confirm if you can hear me clearly?
Yes.
Thank you very much for confirmation. All right, I think I can start now if that's okay with you. Yeah, it's 5 minutes past already from the plan. So, okay, hello everyone. Good night if you are in Asia. I'm Indonesia, so now here it's like 5:30 p.m. And I believe anyone else could be maybe in the morning or if the afternoon. So I hope you have a nice day. So this is the second time that we have the webinar with me, and today we will discuss the topic two, especially about the conversion from the flowcharts to pseudocodes. I will review a little bit about the algorithms and then how we change from algorithm to the flowcharts and then to the pseudocodes. Yeah, and some examples will be discussed as well, including maybe different ideas compared to the videos that you learn from the e-learning. But well, I mean slightly different idea, but actually pretty much the result will be the same. Okay, let me share the screen. Could you please confirm if you can see the screen?
Yes.
Okay, thank you very much. Yeah, as I mentioned earlier, we will discuss about the conversion from flowchart to the pseudocode, and we are now in week 4, and I hope that you follow each topics and each meeting on the e-learning, so you will not be left behind. Yeah. So if you have any question, use the platform to ask me a question. I will try to help. If I cannot answer your question, I will discuss with the tutor, and I will back to you as soon as possible. I can. Thank you. All right, my name is Mohuda, and you can call me Mo. I just graduated my PhD last year from University of Warwick. Okay, let's get to it. Algorithms. So probably you already remember, still remember about the algorithm. That is actually the specific steps that you need to do to solve the problems. That now we will try to convert from algorithm to the flowchart, and then from the flowchart to the pseudocodes. Yeah, so our topic today, it will be conversion from flowchart to the pseudocodes, but I will review a little bit about the algorithm as well. All right, so basically, flowcharts, we can say that flowchart is a set of instruction that use specific diagram shapes or symbols. So there will be different shapes with different meaning, or you can call them symbols as well, to represent the flowchart of the algorithm that you already make to, well, in general, solve the problems, of course. And flowcharts is used to illustrate the algorithm that you already learned the algorithm. For example, in the e-learning, there will be an algorithm in your daily morning routine, and then you change them to represent using the flowchart and then using the pseudocodes. So we are using the flowchart to illustrate these algorithms. We are using the specific shapes or symbols with different meanings for each step to differentiate between each step with each other. Okay, so there are some rules about the flowchart. If you want to build a flowchart, there are some rules that you need to follow. First, it's usually are built from the top to the bottom. So you need to read them from the top to the bottom, or you can represent them from left to the right. And there will be arrow to connect each shape or each symbols of the flowchart to see that the logic is following through step by step logically. The second one, as I mentioned earlier, that the flowcharts are the set of instruction using specific shapes or symbols, right? So all the boxes of the flow charts are connected with the arrows. So the arrows will show the direction of the flow chart to show the logical thinking from step one to step two, what is the next step until the finish of the flow chart. And the next one, that you need to remember that in the flowchart, because this is like the process of something that we need to make them logical in order, there will be start and there will be finish or the end. The start will be using the shapes that we call terminal, or sometimes it's using the process symbol as well. I will explain a little bit about what is actually the shapes that called terminal, called the process symbol, etc. Okay, before we get to the real flowchart, there are some tips to make a flowchart. First, use your own language. In this case, that because I'm Indonesian, so I'm fluent. Of course, I'm fluent in Bahasa Indonesia. That's my mother tongue. I can say that I'm quite fluent in English as well. So basically, I can use English language as well if I want to make a flowchart myself. And the second one, why you need to use your own language? Because it will be easier for you when you make a flowchart, and the follow up after the flowchart, it will be the pseudocode, right? It will be easier for you if you use your own language. You can understand it better, and then you can construct the flowchart so other people can understand the flowchart that you make as well. That's the reason why you need to use your own language, so you can avoid the misunderstanding or the ambiguity in the language that you are using to build the flowchart. And then, of course, use the standard language. Why this is the case? Because, for example, if you speak English and you use like slang language, it's not many people who are not a native to speak English. They will understand what is actually the meaning of the slang language, because sometimes it's quite difficult even for the native speaker. Well, so many slang language, right? So it can be having the different meanings. So use the standard language to make it easier. And you need to input the sentences inside the shapes or the symbols. It will help you that what is inside the symbols, showing the step or the logic that you are now which stage. So inside the shapes or the symbols, there will be sentences or statement or variables, whatever it is related to the flowchart, to make you easier to see which logical step that you need to follow one by one. All right, here we go. So why I call these basic symbols or sets? Because usually the flowcharts always use the symbols that I will mention, but there are more actually, and you can check them. The easiest one, if you open the Microsoft Word, there will be insert shapes. I'm sure you know what I'm saying. And you can check like every symbol, they have like the name and you can use them in the flowchart. The first one that we call terminator. So this is the specific shapes that we call terminator. And usually we are using this at the starting point and using the finishing point. So every time you make of the flowchart, the starting point and the end point, you will use these symbols. So the keyword for the terminator, maybe you can guess. Anyone want to guess? What is the keyword for the terminator symbols?
Start and
Yeah, that's pretty good guess actually. Anything else that probably the synonym of the starting? That's not wrong. Yeah, we do have begin. Well, it's similar to start and right, and finish and similar with end. Because usually in language programming, we will use a lot of the word begin and end, right? And the second one, it will be as the shape represent, it means arrow, right? Well, that's quite obvious. And it's showing the flow direction, the direction of the flow chart. Like I mentioned before, it will be from the top to the bottom or from the left to the right. So the arrow will show the logical step from top to the bottom to the lower stage, and then from the left to the right, and so on. All right. And then the third one that we call the preparation symbols, as the name suggests, it will be the step where we define the initial values. Every time we make the flowchart, many times we will need the initial value that we need to describe the variable first to see what the variables that we need, and we will see the examples, so it will be easier for you to understand what is the terminator, what is the arrow, which one is the preparation, and so on. Okay, the next, it will be the input or output. This is the input and output. And of course, as the name suggested, input or output, it will be represent the data entry by the user. We are the users, and we input the values for each variable that we need. Also, we can see the output of the processing that we already done. Remember that the flowchart will be converted to the pseudocode, right? So basically, it will help us to make it easier how to build the real code before, to build the pseudocodes before we really work with the real codes. And the next, it will be the processing shapes. It will be like rectangle, and it will be showing all the instruction, all the works that need to be carried out by us, by the users. And of course, if you change it in the pseudocodes and later in the real code, of course, this will be in the instruction that carried out by the program or by the computer. Okay, the next one, it will be the decision. Anyone can guess what is the decision about? How can we make the computer to make a decision? What is the decision about in the language programming? Anyone has any idea for what kind of decision, or what is the keyword for the decision? Any idea? No? All right, yeah. Anyone?
sir, we use the symbol to make decision, like we give the condition if or else, and then we maybe if the condition is true, we start making the loop. So this is how this works.
Yeah, that's perfect. So basically, decision in the language programming is just about true and false, right? If true, so the step will be yes, and then it will continue. If not, so there will be, if false, it will be no, and there is another decision taking. Yeah, there will be the decision about the true and false. There will be a different steps, different instruction to follow by the program based on the variable that we input, based on any condition that we use in the programming. All right, so as you mentioned, this is for the selection and repetition, like the loop using if or while in our language programming. And we will discuss more as well by the examples after this. Okay, so the decision basically, well, we can answer the question with true or false, with yes or no. Yeah, so every time you make the flow charts and then you have a question and the answer is yes or no, definitely we will use these decision shapes. So the exit point, which is yes or no, true or false. Okay, example one, calculate the area of rectangular. So let's see the flow chart. Of course, we're starting from the start. That's the terminal. And then we declare the variable. So I can give you the illustration. For example, the variable, it should be like the place where we will put the value inside. It's like the, what you call this one? Let's say this is a bag. A bag is a variable. And you need to put something inside the bag, right? And we can put the clothes. And in this case, the clothes, it should be the value that we will put in the variable. So first we can declare the variable that we need because we want to calculate the area of rectangular. The area depends on two variable, right? The width and the length. That's why we declare the variable for the width and the length. And then the program will read the value of the variable with the length. So that means we need to input the value for each variable. And after we declare the variable, when we give the value by inputting the value for the width and the length, we can calculate the area of the rectangular. So you manually have to find the formula for the area of the rectangular. And then you input the formula, so the program will know what they need to calculate. And then they will give you the result that you want. In this case, the formula for the area is just the length times the width. All right. And then not only we ask the program to calculate the area of rectangular, we want to know the result of the area, right? So that if we do not display the results of the calculation, we will never know unless you calculate by yourself. So in that case, we need to display the area that already calculated by the program. And then, of course, after we know the result, it will be finished. Okay, let's see another example. Let's start from the easy one. Add 100 and 200. Of course, the result is 300. But the idea here is not to make you like clever to make the addition. I know that you more than clever enough to calculate this one. But the idea is just practice how to make a good flow chart from the basic problem. By then you already understand the basic problem 1, 2, 3, 4, and you get used to it, how to make the flowchart and then how to convert them to pseudocode. It will make you easier once you need to make like a big code to solve any problems. So that's why, like when I did my PhD, I need like 100 lines of code that sometimes, not sometimes, many times it makes me got headache, to be honest. But well, that's a good experience. So yeah, I hope you get much better experience than me if you decide to take a further education, either PhD or maybe master or just professional career training or something. Okay. Okay, let's see the algorithm first before we convert it to the pseudocodes. Yeah. So the algorithm, because we want to add 100 and 200, first we need to describe the initial sum. So from the beginning, it should be 0 because we assume that there is no summation, so it will be 0. And then we enter the number. The number here is 100 and 200. And then we declare the addition of two numbers, and then we print the sum of these two numbers. So in the flowchart, we're using the terminal for the start. We're using the arrow to show the logical step or the direction of the flowchart. And then the sum here, sum is equals 0. Sorry, that should be sum equals 0. And then we describe, like I mentioned before, that we need to declare the variables in this case because we only have the value 100 and 200 and the value is not changeable. We can enter the value 100 and 200 directly. and then we define the sum by these two numbers, just sum equals 100 and 200, and we want to see the result as usual, and then we print sum, and that's the end. So it's quite simple, but the idea here is to make you, like I mentioned earlier, to be familiar, to be familiar with how to make the good flowchart and to make it as effective as possible, like I mentioned, because probably for this simple idea, it's quite easy because this is just simple. But if someday you face a complicated problem, of course, the flowchart will be complicated. Like each shape will have maybe two, maybe three branches and so on. And you will have not only, like in this case, only six shapes, probably you will have like 20, 30, 40 shapes with complicated things. So we need to build a good idea how to construct a good flowchart from the beginning by doing the simple case like this. All right. The next example, find the sum of 10 numbers. It's not like 1, 2, 3, 4, 5 numbers, but whatever the numbers that you want to sum, as long as the total, it will be 10 numbers. Maybe 1 million plus 100 plus whatever. And we will try to make the flowchart of this before we convert it to the pseudocode. And in the end, you will convert them to the specific language programming. Okay, as usual, we initialize the sum equals 0 first, and then we enter the numbers that we want, times number, whatever the numbers that we want, add the numbers, and store the result in the sum. Because remember, we not like sum this number directly 10 times, but one by one. The first number, the second number, third number, and so on. And then we always want to know the result, right? So there is a print sum as well. So starting from the start, here we define sum equals 0. Anyone wants to give me what is the idea why there is the definition count equals 0? The previous problem, we do not have count equals 0, right? But why in this case we do have? Any idea? No, not yet. Okay. So that's fine. Yeah, we need to define here as count equals 0. As I mentioned earlier, we want to find the sum of 10 numbers, right? So the count here, we will use the index to show that the number, for example, we already input the first number, second number. Oh, that's still second. We can give more input, the third, the fourth, and so on. So if we input the 11 number, it will be denied. In the end, it will be denied. It means that it will be finished. Yeah, it will not run because it finished already. We only have 10 numbers. That's why we use the count here to define the total number that we want to sum. Okay, enter the number n. That will be the first number, and then the second number, and so on. By the definition here, sum is 0, and then plus the first number that you choose, and then the count, it will be from 0 plus 1, so that the first number, and then we will have. Oh, I didn't realize, sorry. I didn't realize there's an arrow behind this one. Sorry about that. Anyway, okay, and then oh, sorry. There is a mistake. That's not 5. That's actually 10, right? Or it should be 5. Anyone wants to clarify? It should be 5 or 10, or maybe 5, 10 times 10. Anyone realize something? Is it correct or not? Oh, sorry. I need to check. Oh, that's 10. Perfect. Yeah. Thank you very much, James. Yeah, that's 10 because we want to calculate 10 numbers, right? So we need to check is the count less than 10 already or not. Yeah. So because if it's already still less than 10, so we'll keep summing, we'll keep counting. Yeah. The first number, the second number, the third number, and so on. Okay, if yes, we will do the looping, enter the second number, and so on. Thank you, James. Uh, Nah, so as you remember, this is the shapes of decision, right? There are two decision. If the question answered is yes, we continue in this step to continue to enter the second number, and then we continue the steps. And if no, we will have to print the sum. It means that we already have 10 numbers, the first number, second number, and so on. So we'll just print it here. Yeah. We so get the results, it means that it stopped already because it's the final step already. Okay. Oh my goodness, that's not example 3, that example 4. I make a lot of mistakes today. I'm sorry. Yeah, it's quite late in Indonesia. Well, that's not excuse. I just need to check more than once next time. Okay, example 4. So the question is, find the square root of number x up to n decimal places. I do not need to make the algorithm here because in the e-learning, you already got the algorithm and the flowchart for this one, right? So let's see the flowchart because I make a slightly different from the one in the website. The reason is I want to let you know that every flowchart, everyone has the unique flowchart by themselves because the idea to solve the problem, it will be different for each person, right? I mean, like in general, the idea will be the same, but the step could be different for everyone. So this is just the example, like finding the square root of a number. And first, from the start, we will get x and n. X is the number that we want to find the root, and n is the number of decimal places that we want. For example, what is the square root of number 5? If you can just guess blindly, you can guess that square root of 5, it should be like 2 2.1 or maybe 2.3. You will say something like that. That just guess, right? Yeah, so basically we will tell the program to find the square root as precise as possible depending on n decimal places that we want. So in this case, I make this idea. First, we guess a number t. If you remember, anyone can tell me if you already watched the video on the e-learning, what is the different idea here between until this step? What is the difference? Do you realize something? What is the difference if you watch the video already? No one watched the video? I mean, that's okay. I'm just curious if you watch it already. No?
In the flowchart, they say that make a guess of g of square root of x. They didn't mention this equation, g equals to 1 plus n over 2. So this
Yeah.
is different, I think.
Yes, thank you very much. You really pay attention to the video as well. So in the video, I already checked that they said to make a guess, but they do not give the hint how to make a good guess, right? Just because it's, of course, Heron method, it will work whatever the guess that you want. The difference is how effective that the step or the programming will run depend on your guess. For example, the square root of 5, if you choose the square root of 5, it will be 4. Of course, it will be slower than if you choose 2, something like that. So in this case, I make another idea. Let's make a guess. Well, it's not really a guess because I give the idea already that t is equals 1 plus n over 2. Oh, okay. So the next step will be, sorry, my laptop gets stuck. Okay, here we go. Okay, the next, the square root, it will be x over t. And this is, I give the initial value as x0 equals t. This is the number that you guess. In this case, I'm using this formula that I suggested. And then what will we do with these numbers? We need to check is the round of this new number calculated by x over t is actually equal already with the round of the initial value g, because we need to make a decision, and because we want to find the square root of a number, of course we want to get as precise as possible, right? But as the programming suggested, of course, it depends on the error that we want. For example, the square root of 4 is 2, but if we can make a guess 1.87, that's not really correct, but it's not that too wrong because the error value is just 0 point something, right? So we use this decision. So if the round is equals, if not, so we need to continue to the next step. And what we will do is calculate by guessing the new t. Well, in this case, it's not guessing again, but we just calculate the value of t by using this formula. The xr plus x0 over 2. And then after calculate that, we continue the process. And then if the decision that the round of xr with the n decimal places is equal with the initial value of x0 with n decimal places is equal, so the output is just the run of the new value that we got, which is the square root estimation of x, which is xr with n to decimal places. In that case, it will be finished. Yeah, it's actually the similar idea. This is also Heron method, but the difference is just in this step, it's not blindly guess the square root of the number. It's just giving the suggestion that it will be starting from this formula 1 plus n over 2. Okay. Now we continue to the pseudocodes. As the name suggested, pseudo is actually from the Greek language pseudos, and it means false. Why this is called false? Because the pseudocode is not real code. Yeah, it's just the pseudocodes. Yeah, it means that the pseudocode is running by the person, not by the machine, because the machine, the computer, will run the real code. Yeah, remember that. Okay, so basically I can say that the pseudocodes is a set of steps to solve the problem using the codes, but not related to any specific language programming. So it's just the general idea how you make like the code, but it's not the real one. It means that you cannot really run this code, of course, because it's not bound to any specific language programming, even R, JavaScript, Python, Julia, and so on. Okay, some properties of the pseudocodes are first, again, this is not actual programming language. Therefore, it's not related to any specific language programming. Yeah. So basically, any pseudocode that you make, it can be applied to any language programming. Second, a simple language pattern. Why this is called simple language pattern? Because you basically also use the similar language that you use in real code, but this is just a simple one because you already have from the algorithm and then to the flowchart, that's simple already, and then you use the pseudocode, if, then, else, while, etc. And then the third one, there is no standard procedure. Like I mentioned earlier, that when you have the algorithm to solve the problem, everyone has different idea how to solve the problem, right? So it means that everyone can build a different flowchart as well, right? So it implicates if the flowchart is different, of course, the pseudocode is also different. Therefore, there is no standard procedure. It means that you don't have to do step 1, step 2, like exactly the same by your friends or by the professor. No, but just need the idea is the same, but the way you construct the pseudocodes, it can be different. All right. And because like I mentioned in the earliest, that the step it will be from algorithm and then to flowcharts and then to pseudocode, we can say that the pseudocode, it should be the high level representation of the algorithm. Yeah. However, without trying it to use in specific language programming. As I mentioned earlier, that the pseudocode is not bound to any language programming. Okay. Okay. So there are some tips how to write the pseudocode. So in general, pseudocode has a writing format. I summary the writing format in pseudocode in 3 parts. First is the title. Write the title of the algorithm. Why this is important? Because as I mentioned earlier, someday you may face a really complicated problem. Sometimes it consists of several interconnected program 1, program 2, program 3, function 1, function 2, and so on. So if you do not give the title, it will be difficult for you someday if you read it again, what is this code about? So the title here to make it easier to identify how this code is about finding the square root of a number or checking the number is even or odd or something else. Okay. The second, it will be description or declaration. It will be the step that you declare the variables that you are using. Probably there will be one variable, second variable, third variable, and so on. For example, the simple one, calculate the area of a rectangular, you will need only two variables, right? Length and width. But if you need to calculate the volume of the cube, you will need three, right? X, Y, Z from the length, from the height, and from the width. That will be different as well. Not to mention if you need to declare many more variables. So because some formula, it will have 4, 5, even more variables in the formulas. That means that you need to declare more variables. And the last one, it will be the implementation. After you declare the variable, the implementation is basically the core of the pseudocodes or the codes. So the implementation, it will be the main focus when you are writing the pseudocodes or the real codes. All right, let's see the example. Example 1, calculate area of rectangular. We already have the flow chart. Let's see the flow chart again. All right. So we declare the variables length and width, and the implementation, we just input the value of the length and the width, and then we just calculate the area by using the formula that you define. And then don't forget, you always need to display the result if you want to know the value of the calculation that you want to know. Otherwise, it will be stored on the machine, but you cannot see the result. However, sometimes you do not always need to know the result if you are sure that the code is already correct. So you are sure that the result is correct, and you need to use the value for the next function. So you do not need to display them, because sometimes the output of the programming, it will be like a huge table with many observation and variables. So sometimes you do not always need to display the output. Excuse me. All right. Example 2, checking the odd or even numbers. So the flow chart, it will be like this. There will be a decision to make, because we want to check the number is odd or not. So we need to check if the number modulo is 0 or not, modulo by 2 is 0 or not. Because the even numbers defined by the number that can be divided by 2, and the residual, it should be 0. So that we need to check if the modulo 2 of that number that we want to check is 0. If yeah, so that's true, so we are finished. If not, so the number is odd, it's finished as well. So if you want to make the pseudocode, it will be on the right hand like this. Again, we have title, and then we have declaration, and then we have implementation as usual. Yeah. Okay. Let's see the next example. Write the pseudocode to calculate the amount of fuel a train used to complete a journey. With some condition that the algorithm must first. So in the pseudocodes, it will have this step first, as the user how many kilometers the journey will be. The second, it has to be continue only if the user give the specific number which is greater than 0. And the third one, we can set the fuel amount to a number 150 150 times the greater than the number of the kilometers. Yes. So if we have the distance of the trains travel, for example, 100 kilometers, so we need to times 100 by 150. That will be the amount of the fuel that will be needed. And there will be the condition as well that the fuel amount must be greater than 2000. It means that the less fuel that should be inside the train, it should be 2000. Yeah. And then, of course, in the end, we need to display the fuel amount used because we want to know the amount of fuel that the train uses to complete the travel. Okay, so this is the pseudocode. First, we need, again, we need to decide that the fuel amount as usual is 0. And then the second one, remember that in the algorithm, we have to ask the user how many kilometers the journey will be, right? So we input here how many kilometers traveled. So the train, for example, traveled for 100, 200, and so on. That's why we need to input the value. So we need to check if the kilometers greater than 0, yeah, because there is a condition that it's only continue if the number is greater than 0. Of course, because the train need to travel some distance, of course, it should be greater than 0. Yeah. If it's greater than 0, then the fuel amount, as we described already, that it should be times by 150. Excuse me, sorry. There is mistype as well. There is no equal sign here. Actually, it's 150 times the kilometers that the user input. Okay, and if the fuel of amount less than 2000, what will happen? What do you think will happen if the fuel amount less than 2000? Any idea? Look at the algorithm. So what do you think will happen if the amount is less than 2000? Okay, because we already defined that we need to set the fuel amount, that we need to have the fuel amount, it should be greater than 10,000, 2,000, right? So if the fuel amount less than 2,000, it will be printed as the fuel amount is 2,000. Then we got the output fuel amount. In the end, if the fuel amount not less than 2,000, and then we will have output the fuel amount by the calculation 150 times the kilometers. Okay, before the end of the session, I will give you the top tips. Yeah, to write and understand the pseudocodes, I can say that well, writing the pseudocode is not that easy, but it's not that difficult as well. But it will be easier if you write and understand the real code first. Yeah, it means why we need to understand the real code first. We don't really know the real code first. That's why we learn about the pseudocode. But why we need to understand first? It means that you need to understand the real code first. It's just like the basic thing. For example, if you learn about the R language programming, you need to familiar yourself how to declare a variable, how to assign the value for the variable, and then how to use the proper name for the variable, and then how to store, how to do the loop, etc. So it's basically just the basic the basic idea about the real code. It will be easier for you to write and understand the pseudocode once you already learn and understand about the real code first. And the second one, make the pseudocodes looks like a real one. Remember that the pseudocodes basically is a bridge, yeah, between the flowchart and the real code. It is supposed to help you easy to make the real code. Yeah, that's why you need to write the pseudocodes look like exactly the same real code. That's why we have if, then, and then print or display, etc. However, it's just in simplified form. Yeah. And the third one, practice. Of course, a good practice makes perfect. Remember, yeah, not only practice, but a good practice makes perfect. It means that you need to practice in proper way, write the pseudocodes, like don't skip every step when you think that, oh, I understand this already, okay, I'll just skip it. Don't do that, because practice, a good practice, it will make you familiar with step by step logic, the logic to solve the problem. So it will make easier when you deal with the real code. Yeah. And some tips as well, because in the end of the day, you will have the exams. So try to do the past paper questions, either try to try to write the algorithms, try to build the flowchart, and then try to make the pseudocodes. Yeah, try the past paper question. It will help you to prepare yourself much better for the exams. Oh, there is a question. Sorry, let me check. Is it possible to go over some difficult questions from previous year exam papers during upcoming webinars? Many of us discuss it with Tim, the module leader during the welcome webinar, and he agreed we'd like to incorporate it into the tutorial webinars as well. Oh, okay, yeah, that's a good idea actually. I will talk to Tim as well, because I need him. I'm not sure if I have an access for the past papers, but I will try to ask him, and then I will let you know. I'm sure that if I do not have the access, he will be happy to give me an access for the past papers. So why not? And it will be helpful if probably you have any question or which number that you want to discuss for the webinar, and then I will prepare for it. Yeah, just in case I do not misunderstand, that's the correct answer that you want to, sorry, not correct answer, the correct question that you want to discuss. Just in case, for example, the past paper one, I prepare the past paper one, that the one that you want is actually the past paper two or something like this, just to avoid the mistakes. Okay, yeah, I will talk to him. Please forward it to the other tutor as well. Yeah, sure. I will post after this, right after this, I will post the, before I forgot, sorry, I will need to take the screenshot for this one. Exactly the sentence that you write, if that's okay with you. I will copy it in the all tutors that this is the request for the students, if that's okay with you. If not, I can paraphrase, of course. So yeah. Okay, so I guess you agree that I will just copy what you are mentioning. Is it possible, blah, blah, blah? Because it will be easier for me to pass this information to avoid any misunderstanding from me while understanding your sentence, if that's okay. Oh, you agree. Perfect. Thank you very much. Okay, I will continue. It will be the end already, actually. Yeah. And the last one, be consistent with your pseudocodes. It means that when you are consistent with your specific language, anytime you write the pseudocode, it will be easier for you. For example, the uniqueness, the way I give the name of the variable is I using underscore, I using the dot, or I using the abbreviation of something or something like that. It will be easier for yourself. As I mentioned earlier, someday you will deal with a very complicated a code, right? And it will be easier for you if you consistent with yourself. At least it will be easier for you to understand your own codes before other people understand it. All right, the last one, remember again, your pseudocodes will never be run. Yeah, remember, this is not real code. Of course, if you copy paste your pseudocode, for example, in R language programming or JavaScript, and you try to run, it will not run because this is just pseudocodes. All right, thank you very much, guys, for coming today. If you have any question, I will be happy to answer. So if you have any problem, anything, as long as I can help, otherwise I can ask my colleague. You are welcome. Thank you very much, guys.
Sir, I want to ask one thing. In the start, you mentioned one shape.
Yeah.
Part
One
and then you didn't use it in any other.
one shape. What do you mean? Which one?
I think it's called pentagon. It's something like that. Can you please check it in the
Oh,
slide?
sorry. Is it this one?
Yes, this initialization one, third
Oh
one.
yeah, this one. Yeah. So in the pseudocode, sorry, in the flowchart that I'm using, I do not use any this one because it's enough to use another shapes. So it's basically just
Okay.
the initiation or defining initial value. So for example, if you have, are you familiar with differential equation? Or maybe not.
Differential equation, yes.
Oh yeah, so in there will be the boundary problem with the initial value, right? That we want to decide, that we want to
Mm,
define first the initial value problem.
mm.
You can use this one, but in our problem that I give you the example, we already define direct value like the length, what is the length, what is the width, and something like that. So you do not
Okay.
need to use all the shapes in one flowchart. You just need to use any shapes that you think it's enough to use in the flowchart. Yeah. Even if probably
Mm.
only 3 or 4, that's enough. You don't have to like use 5, 6 to
So
make it.
I think this shape is used for declaring the variable like we did in the code. So in the real code, we declare the variables first and then we initialize them. So I think this shape is used for declaring the variable.
Sorry,
Declaring the variable.
declaring the variable.
Yes.
Oh yeah. Yeah, so we have another shape like this. Which
Input.
one? You mean the different with this one?
No, no, no. I was asking the previous one, then in the last slide.
Yeah,
No,
this
this one.
one.
No.
Yeah,
Yes, this
yeah,
one.
correct. This one, right? What you mean?
Yes.
Did you say different variable with this one? Sorry, with this one.
I am asking about this preparation one. I am asking that we use it for like declaring a variable before initializing the variable like we did in the code. We first
Oh,
declare the variable and
declaring.
then we initialize it.
Yeah, yeah, that's correct. Yeah.
Is it this way?
Mhm.
Okay. Thank you.
Yeah, yeah, no worries. Sorry. My English is not that good. Sometimes I,
It's okay. It's okay.
sorry about that. It's only a year I left the UK and my English is getting worse. Sorry about that. Thank you very much for the question. Anyone else? No? If not, I just need to remind you that you will have like mid exams probably in week 11, and now we are in week 4. So the best advice that I can give you is just spend at least a few hours a week to watch the videos or read the references that suggested on the e-learning. Otherwise, you will be got headache with a lot of work that you have to do at the same times, because in the midterm you will have a lot of assignment, a lot of midterm exams, etc. So that's the best advice that I can give you. Okay, if there is no more question, thank you very much for today. I hope you have a nice day and always keep the spirit high and be happy learning. Yeah, and see you then. Bye bye.
Bye.